Now similarly same point we already learned linear expansion. Now our next point is areal expansion is similarly to linear expansion. So linear expansion means change in length, but now here areal expansion means increase in surface area. Okay, suppose here metal plate, square metal plate, and is heated, then its area is changes. So change in area is small change in area is delta, consider as delta A. So see your definition. So linear areal expansion is the increase delta A in the surface area on heating is called areal expansion, or also called a superficial expansion. Okay, so delta A upon A is directly proportional to the delta T. Means the increase means a substance is the form of plate of area A, then small change delta T in temperature. So delta A upon A is equal to beta delta. Small change in temperature. Delta A upon A is equal to fractional change in area, and beta is the coefficient of areal expansion or solid, means coefficient of superficial expansion. Okay, so therefore beta is equal to delta A. Now rearranging this equation, delta A upon A into delta T. So delta is nothing but a change in area. So AT minus A naught. So A naught means area at 0 degree Celsius temperature, and AT is at T degree Celsius temperature. Okay, so area at T degree Celsius temperature upon A naught. A naught is also initial area. So T minus into bracket of T minus T naught is also change in temperature. So delta is written as AT minus A naught, and delta T written as T minus T naught. Okay, this is the equation number 2. This is the equation number 1, and this is the equation number 2. So here A naught is area of the plate at 0 degree Celsius. AT is the area of plate when heated to T degree Celsius. So T naught is 0 degree Celsius is initial temperature, T is the final temperature. Delta is the AT minus A naught change in area, AT is the T minus T naught rise in temperature. We already learned. So rearrange this equation is AT minus A naught is equal to beta A naught T minus T naught. So AT is equal to A naught plus beta A naught T minus T naught. So AT is equal to, we get A naught is the common point. So 1 minus beta T minus T naught. Here T naught means change in temperature written as a T. So we get a final formula AT is equal to A naught 1 plus beta T. Okay. So here you know that the definition of coefficient of areal expansion is defined as the increase in the area per unit original area at 0 degree Celsius for 1 degree rise in temperature. Okay, so this is the formula for coefficient of areal expansion or superficial expansion. So SI unit is also per degree Celsius or per Kelvin. Similarly point here, next our point is volume expansion. So linear expansion means change in length, areal expansion means change in area. So now volume expansion means change in volume. So the increase in volume due to heating is called volume expansion or cubical expansion. So now here consider a cube is heated, then all side is changes. So here change in volume. So here delta V upon V. The figure shows here delta change in expansion in volume. So if the substance V is the form of cube of volume V, then for small change delta T in temperature, the fractional change delta V upon V as shown in your figure in volume is directly proportional to the delta T. So or delta V upon V is equal to gamma delta T. Okay, so alpha, beta and gamma is the coefficient of linear expansion, areal expansion and now volume expansion. So this is the coefficient of, so gamma is the coefficient of volume expansion. respectively. So where delta T is a small change in temperature, delta P upon a fractional change in volume, and gamma is the coefficient of cubical or volume expansion. Again, rearranging this equation, gamma, so we get delta V upon V into delta T is equal to Vt minus V naught upon V naught T minus T naught. Here same quantity here, where V naught is volume at 0 degree Celsius, Vt is volume when heated. So T naught is 0 degree Celsius is initial temperature, T is the final temperature. Delta V is equal to Vt minus V naught rise in temperature, and delta T is T minus T naught rise in temperature. Similarly, we find another formula for Vt. So Vt minus V naught is equal to gamma V naught T minus T naught. This rearranging this equation, then Vt is equal to V naught plus gamma V naught T minus T naught. Here V naught is a common point, so we get a formula Vt is equal to V naught 1 plus gamma T. So definition of the coefficient of cubical expansion of a solid is defined as increase in volume per unit original volume at 0 degree Celsius for 1 degree rise in temperature. Okay, so another formula, same formula for gamma is equal to 2 minus V1 for first volume expansion to the final second V2. So V2 minus V1 is equal to V1 in bracket of T2 minus T1. Okay, so this formula, and this formula are some different form of formulas for gamma is the coefficient of cubical expansion. Our SI unit is gamma is per degree Celsius or per Kelvin.